So we have used the brute force algorithm to find the solution of a partial digest. Now we will see and add the actual values in the algorithm we have already devised. So here we can see the width we have already called it the maximum element in L, and we know that L, the maximum element was 10. So that's why we have taken it as a maximum element. Now second step is delete width from L. So we have deleted 10 from this L. Now we have put this value of width in X, and we have already decided that the 0 is X1, so that's why we have already 0 in the X, and the second value will be the width, that is the maximum value in the L. So now we have calculated two values in the X, 0 and 10. Now we will place the value of L and X. L is 0 and X is 10, and X is 0 and 10. So we have placed the value 0 and 10 here. Now we will place the values of L and X. If L is empty, then we will get the answers straight away and it will return the answer. So if L is not empty, then we will put the value of Y as a maximum element. So here the maximum element is 8 because 10 is already shifted to the X, so we left with the 8 as a maximum element. So next is the delta Yx. If subset of L, then we will add Y to the X. So we will calculate the value of delta Yx. Here Y we assume the value of 8 because the maximum largest element in the L. So we calculate the Yx with Y value of 8. So we'll calculate 8 and 10. 8 and 10 is not a subset of L because 8 is here but 10 is not here. So if it is not the subset of L, then we will move to the next part of the algorithm. So here we can see L is this one, X is 0, 10. Now we will calculate the width minus Yx, and we know width is the maximum element in the L, that was 10. Now we will minus the 8 Y, and we assume that Y is 8, that is the maximum element now in the L. So we will minus 10 from 8, and we have the value of X 0 and 10. So we will calculate 10 minus 8, 2, and we will, after calculating all this, we will get 2 and 8. So 2 and 8, they are present in L. So this is the subset of L. And we have already seen that in the actual problem, we have taken 2 in the X and we have removed 8 from the L. So this way we can solve the problem step by step. So in the next step, we were left with this subset of L with the highest element of 7, and if we will put the value here, delta Yx, if it's subset of L, then we will add the Y into the X, and we know here the value of Y is 7 and the X is 0, 10 and 2. So after calculating, we will get this one. So we can see here 7 is here, 5 is here and 3 is here. So it is a subset of L. So we will add the value of, we add the 7 in the X. So it will become 0, 2, 7 and 10. So this way we will continue and we will get the answer. So in the next slide, we will see that now the value of the L is 2, 3, 3, 4, 5, 6, and we have got the X 0, 2, 7, 10. So you will remember that we will go up to the level of 5, we have to calculate the n is equal to 5. So we have left with the 6, that is the highest element. So again we will put the value of 6 and we'll try to calculate with the x. So y is 6 and x is 0 to 710. And after calculation we get 6414. We will see whether it is a subset of L or not. 6 is here, 4, 1 and 1 is not here. So it means this is not a subset of L. So 6 cannot be included here. So if it's not the subset, then we will proceed to the next part of the algorithm. That is, we will minus the value of y from the width, and we remember width is 10. So we will put the value of width as 10, y is 6 and x is this one. So after calculating we get this one, 4, 2, 3 and 6. We can see here 4, 2, 3 and 6 all are present in L, so this is the subset of L. So it means we can finally take the value of 7, this one 7, and put it in the x. So we get the x 0, 2, 4, 7 and 10. So this way we can calculate the real-time problem in the algorithm of partial digest, and for this we use the brute force algorithm. And we can apply this information for actual partial digest problem of DNA. So if we have a subset of L different points of fragments lengths of DNA, we can calculate the distances between the restriction sites.